My name is Aaron, and this is my Chapter 1 FRQ test corrections. And, for step 1, we're asked to derive an equation for the vertical coordinate y of the sphere as a function of x, v0, and physical constants that is appropriate. And so this is our thing. And we'll start with the equation x equals vx0 t plus a 1/2 at squared. And since it's a 2D equation, we'll also need one equation for the y component as well. So for this, we know that in our x coordinate we do not have an acceleration, so ax equals 0. And this will cancel out this part. We're left with x equals v x0 t. And for our y component, we'll also have the same equation of y equals v y 0t plus 1 f a t squared. And since our object is launched in the x coordinate, our initial y velocity is going to be 0, so we cancel out this part and we're left with y equals 1/2 a yt squared. Now for this, we're going to need to find a bridge to connect both equations, and since both equations have t in common, we'll isolate this to solve for t, so we'll divide the entire thing by vxo. So we get t equals x divided by vxo. And we'll plug this part into the y equation, and we'll get y equals 1/2 a x divided by vx0 squared. And the mistake I made for this problem was I wasn't able to figure out which equations to use and how to plug in the stuff, so I didn't have a response for this part A. And for part B, we're asked to design a procedure to prove that y is proportional to x squared. And so for our procedure, we'll start with since we have a launcher, a vertical launcher, we will first we'll measure the height of the launcher with the meter stick and place the carbon paper below in front of the launcher and set it to a certain height. For step 2, we will place the ball in the launcher and launch it and record the and find the distance from the launcher to where the spot on the carbon paper is. And to reduce experimental uncertainty, we will need to repeat step 2 at least 3 to 5 times. And, for step 4, we will need to repeat steps 2 and 3 with different y values, and that will be our procedure for part B. And the next part is asking us to what quantities will be measured and what symbol and what equipment we'll use to do it. For quantity, for the first one we'll need is the height of the launcher. And for this, we'll use y as our symbol, and equipment we'll measure with the meter stick. And for the other quantity, we will be measuring where the ball lands, just the X component. And we'll be using X to be our symbol, and the equipment we'll use is the meter stick. And that's this part. And for the next part is the next part is where we have the values and we'll need to change it so we're able to graph it. And since we were asked to prove that y equals x squared, we need to prove that this is proportional. We're going to need to multiply this part by, we're going to square this part, and that gives us squared meters squared. And the values 0.5 squared is 0.25, 1 squared is 1, 1.5, 2.25, and 2 squared is 4. And so for part C, we need to graph this to prove that y is proportional to x squared is true. For this, our vertical axis is going to be y and m, and our horizontal is going to be x squared and squared. We'll label that on the graph. And since we need to label the graph, so we'll be able to use the whole graph. We'll put, for our y values, will be 0.2, 0.4, 0.6, 0.8, and 1. And for our x values, since our numbers are smaller, we'll use 1, 2, 3, 4, 5. And to graph, our first x value will be 0.25, so it'll be around here, and as a vertical displacement of 0.65, so it'll be around here. That's our first point. And our next point is at 1, so it'll be here with vertical displacement of 0.245, so it'll be around here. And our next one is at 2.25 with vertical displacement 0.56, around here with around here, and at 4 we have a vertical displacement of 0.99 here. And this was graphed more accurately. It will be a straighter line. But since we have a straight line, we could prove that y is proportional to x squared, because since our graph is a straight line, that means it is proportional, because the graph of a proportional equation is linear. And that wraps up this part. And the part that I got wrong for this was I didn't realize that we were supposed to prove that y is proportional to x squared. So I ended up graphing y equals x, and my graph ended up looking like this. So an exponential graph, and I ended up getting the wrong answer. This resulted in me having a different answer for y is proportional to x squared and having no as my response, and also having a graph that was not right. And that's the text questions.